I'm not drinking 3 beers. But. Hello, I'm Stefan Prodan. I work for Weaveworks. I'm part of the developer experience team at Weaveworks. I'm doing mostly integrations and hacking on different things on Kubernetes. And today I want to talk about my new experimental thing that's called Flagger. And I've named it, I don't know, an Istio progressive delivery operator. I set my goals with this. It's not all about progressive delivery. Progressive delivery is a term coined by RedMonk. You can go to the RedMonk website and it's an interesting article about it. What progressive delivery wants to say is that it's a way to define continuous delivery with things like Canary deployments, A/B testing, feature flagging, and all this stuff, right? Why it's different from continuous delivery? Because it has this goal of giving you more confidence when you deploy things in production. Like, we all know, no matter how much testing we are doing before going to production, something will.
Well, I thought I'd say sorry, what it is.
Yeah, okay. So the idea behind progressive delivery is that you can test something in your production environment by manipulating traffic. So you just don't just roll out your new version and that one crashes and yeah, you're in a bad spot. The building blocks for progressive delivery are user segmentation, so you need somehow to differentiate your users. You need a traffic management solution. You need observability on top of that, and of course, automation. Istio does the first three things. You can do it easily with Istio. I think everybody here has played with the Istio demos, and you can see you have V1, V2, you can make some changes in a YAML, apply that YAML, and you can route traffic between two versions of your application. But, okay, you can do Canary deployments, you can do A/B testing, but all these things are manual. If you have hundreds of microservices, you don't want to be spending your time modifying some YAMLs, incrementing some weights, looking at some graphs, take a decision, oh, it looks good, I will increment the weight and so on. What Flagger does, it tries to automate, for now, only Canary deployments based on metrics. And especially the Prometheus metrics that Istio exposes. So if you install Istio with the full pack, you'll get a Prometheus server in the Istio namespace, and you'll get metrics like error rate, latency, and so on. So if you have all those metrics, you could actually build some automation based on that. And Flagger implements a control loop, which basically it looks at some Prometheus metrics, takes a decision based on those metrics, and advances the deployment. What that means, it gives more traffic to the Canary deployment. And how you can install Istio? I made a Helm chart for it. It's hosted on GitHub. There are two Helm charts here. One is Flagger itself. You deploy it in the Istio namespace, or you can deploy it in another namespace. What's important is that you tell Flagger where the Prometheus instance is. And the second Helm chart is it's a Grafana dashboard that I've built especially for Flagger, so you can see what's behind the automation. How it works is I try to make it very easy to create all this Canary stuff. So you'll give it a deployment spec, a deployment file, and a custom resource called Canary, and I will show you later how that custom resource looks like. But you give it a single deployment file, and from that, Flagger will bootstrap everything you see here. Cluster IP services, Istio, virtual service, and so on. So it don't control all these things. They are owned by Flagger and by the custom resource that contains all these details. How Flagger takes the decision to advance a deployment or to roll back a deployment, stuff like that. It uses, for now, only 3 key performance indicators. One is the deployment health status that comes from Kube API, and request success rate, percentage, and request latency average value. These 2 metrics come from Prometheus, provided by Istio. So in terms of observability, Flagger emits Kubernetes events. So for example, if you'll do kubectl describe a particular Canary release, you'll see here everything that Flagger does. The status of the deployment, if it fails or not, all the steps I've tried to log as much information as possible. And you'll see this in a demo. This is how the Grafana dashboard looks. And on to give you a short overview of the custom resource. So the custom resource is named Canary, and inside this custom resource, you tell Flagger where the deployment is, which deployment is. In this case, its name is podinfo, and you can optionally tell Flagger if you have an horizontal pod autoscaler in there. You may want to do that if you have lots of traffic in your system. Afterwards, you tell it what port is your application exposing, and if you want to expose this application outside the mesh. If you want to expose it outside the mesh publicly, let's say, you need to tell Flagger which are the Istio gateways and on what host or hosts you want your application to be exposed. These 2 informations are needed to construct the virtual service definition. And the last part of the Canary spec is the Canary analysis. And here you can set different things. For example, you can set the threshold of failed checks. So you'll see that Flagger at a particular time, like let's say 1 minute, it will get to Prometheus and it will check different things like the success rate and the latency, for example. And you can say here, if it fails more than 10 times, roll back the Canary and mark it as failed. Also, you can set up a max weight and the step of the weight. So let's say you can start from 1% of the traffic. It will increase 2%, 3%, and so on until it reaches a maximum weight. In this case, it's like 50% of your production cluster. At the end, we'll go to the Canary release. If that's successful, it will do the rollover or not. And below, you can specify the metrics name, and you can set a threshold for each metric. For example, here I'm saying if less than 99% of all requests are errors, fail the deployment. Or if the average value, the 99% of the latency average value is above 500 milliseconds, fail the deployment. And you can also set the interval. For example, for what interval should Flagger calculate this average value? This is how the deployment stage looks like. So you start with, let's say, V1. You will deploy your new spec, the Canary spec. Flagger will scale out to one replica, your new deployment. Afterwards, if you have an horizontal pod autoscaler, the horizontal pod autoscaler will start to add more replicas, and Flagger will increment the weight, the traffic, to the new version. If everything is okay, so this is the happy path. If everything is okay, it will do a rolling update for the production workload, and it scales down, it destroys the Canary. And here is how Flagger interacts with all these objects. Talks to Prometheus, of course. It checks the primary and the Canary deployment, and it modifies the weights in the virtual service. And it waits for the HPA to do its job. So if the HPA will start to scale up or down one of those deployments, Flagger will halt the advancement of the traffic. So it waits for things to settle, and afterwards it will give it more traffic. Okay, so start the demo. I will be using GitOps to do the operations on the cluster. What that means is I will not use kubectl apply. I will use Git repo, and I will modify something in my repository, and another operator called withFlux will synchronize the state from my Git repo to the cluster. So instead of operating directly on the cluster, I'll operate through a Git repository. So this is how my Git repository looks like. I'm having here workloads, the production namespace, and I have here 3 files. One is the deployment, so it's an usual deployment declaration, nothing special about it. You can have whatever you want in here. And I'm having the horizontal pod autoscaler. And here in the horizontal pod autoscaler, I'm setting a minimum of 2 replicas to show you how Flagger waits for the autoscaler to do its job. And I have here the Canary spec, which looks the same as the one I've shown you before. So here is the Grafana dashboard, and you can see that only the primary deployment receives traffic, and the Canary deployment is scaled to 0. There is no data for it because I'm not deploying now Canary stuff. I will start load test so we can get more data. And now let's say I will modify something in the file, in my deployment file. So it doesn't look only for the Docker image. You can modify whatever you want in here. Let's say you modify a parameter, you modify limits, CPUs, whatever. Each modification is treated as something that goes through the Canary process. It's not just I'm deploying new code. Maybe some change in the configuration could affect your production workload in such a way that you'll fail or something like that. So it doesn't matter what you change in here. Flagger does a checksum of what's running in your cluster, and when you push a new deployment, it detects any kind of change in the spec of the deployment file, and it will just do its thing. let's change the color here. Okay, so I'm committing this change. You can use kubectl apply. You don't have to use GitOps. You can use your CI system to do deployments. You can do whatever you want. Flagger runs inside your cluster. But yeah, we prefer to do it in this way. So now look at the logs. I don't know. Should I make it bigger? So what happened, the new deployment has been applied on the cluster, and Flagger has detected that there is a new revision of that deployment. And afterwards, it checks to see if there is a rolling update of that deployment. And as you can see, first of all, he scaled the deployment to 1 replica, and it waits to have that replica running. Second of all, the HPA will detect, oh, the deployment has started, and it will scale 2 replicas, and Flagger will also wait for that. Once everything is settled, it starts to advance the traffic. So now it got to 20%. And we can see here that the primary traffic goes down, and the Canary traffic goes up. So it slowly starts to shift traffic towards the new deployment. What I can do while it's doing that, I can, let's say, I will generate some 500 errors. So I will call my app, and it will result in 500 errors. And hopefully, Flagger will halt the deployment because it sees this error happening. Well, it didn't. Try again. Yeah, I wasn't fast enough. So the Prometheus that comes with Istio has a delay. It will scrape all the Envoy sidecars every 15 seconds. So I didn't give it enough time to receive the information. So I will just do another modification. Let's say this time I will increment the version here. This you'll probably do with your continuous deployment thing, whatever you have. Okay, so I'm trying again. Let's see. So WeFlux now has synchronized the new spec on the cluster. Okay, and now we'll do again the error thing. Let's hope it works this time. So there are two metrics that Flagger looks on. Is the request rate and what responses does that receive, and the delay. And we can also, we'll also play with the delay. So okay, it's happening. I'm gonna stop the errors now. And you can see here in the logs it says that the advancement has halted. What that means, it stayed at 5% traffic because the error rate got under the threshold I've set up in the deployment spec. So I've set up 99%, and now the success rate is at 82, 86. And it starts now to go back to 100% because I've stopped the error generator. And I can also do delay, generate latency. And now Flagger has detected that, okay, the average duration got to 2 seconds, and the threshold was set to 500 milliseconds. And because it will reach 10 errors at some point, it's close now, it will roll back the Canary deployment. What that means, it will scale back to 0, and it will give it 100% the primary. So you will not advance that failed new deployment into your production cluster. Of course, 5% of your traffic will have all these errors, will encounter all this latency, but it's 5%, is not 100%, right? That's the whole idea behind the Canary. And now we said Canary failed, scaling down. So here in the Grafana dashboard, maybe it's more obvious. What happens, the success rate went down, the latency went up, and here there are the 2 pods. And if we wait a second, you'll see that those got to 0 again. Yeah. So now everything is scaled down, and all your traffic goes to the primary deployment. Now you may wonder, okay, so Flagger will create all these deployment objects for you. But when it does that, it checks if those objects are already there. So let's say you want to be in control of your virtual service declaration. If you add the 2 backends, like Flagger wants, and this is documented, you can be in control of your virtual service. You can set up whatever you want there, and Flagger will use that virtual service instead of creating one. Also, the cluster IP services, you can have, I don't know, things in there that Flagger will not put by default. It just has the Istio convention that the port that your deployment exposes is named HTTP. If you don't name the port HTTP, you'll not get all these metrics. So that's why Flagger does that for you. It's kind of tricky. There is documentation about how you get all these metrics, and there are some conventions that Istio looks for. And Flagger follows all these conventions to get the metrics, to get open tracing also, and all this stuff. In the future, what I want to add to Flagger is the possibility to also decide if a Canary is successful or a Canary failed based on custom metrics. So you can instrument your application and expose other metrics that what Istio does, right? And maybe you want to have those performance metrics as a decision if you, let's say, promote or not, but you want to add to this performance metric some business metrics, and Istio has no idea about that. You can, I don't know, instrument your application, expose those metrics, point Prometheus to your application to scrape your application, and you could add those custom metrics to Flagger. Let's say you decide on requests per second, latency, but you also decide on other things that are, I don't know, queue length or whatever other things are in your systems. Any questions? Thanks. Yeah.
I was just wondering, do you plan to be like married tightly to Istio and Prometheus, or are you taking this further? Maybe like there can be different meshes that you can use to shift the traffic, different monitoring systems.
Yeah, it's a good question. Right now, Flagger uses so. Yeah. So the question was, is Flagger going to work with other service meshes besides Istio, right? I hope it will work soon with Linkerd 2. I'm using right now, so Istio doesn't have a Golang client. It doesn't have a client at all. So luckily, Knative created this client, the Kubernetes client for Istio, because they need it. They do stuff like that. So I've used that client, but you can if there is a Go client for a particular service mesh, it's pretty easy to go into the code and add this capability to Flagger. It's not too much code. You can check it on GitHub. I also have a site for it, is flagger.app, but yeah, the repository is here. When it comes to metrics, you could probably have other backends as well. Maybe InfluxDB or something like that. Of course, you need a way to query that and should expose all these metrics. But replacing Istio with something else right now is not the first goal that I have for Flagger. My first goal is to make it work really good with Istio and add custom metrics to it. Have here a roadmap. So there are several problems. First of all, it deals only with deployments, right? But what if you have config maps and you use the config map to change something in your application? You will want a Canary release for that. Right now, Flagger doesn't support that. It doesn't look at other things outside the deployment spec. So one way will be to extend the things that Flagger watches to config maps, secrets, and other things. Another thing that I want to do is add support for Helm releases, because it's another way of packaging your deployments. A Helm release contains deployments along with all the configurations. So this can be quite easy to implement. And instead of telling Flagger about a deployment spec, you'll tell Flagger about a Helm release. And it can do the same thing for a Helm release, or open fast functions, Knative functions, all the things, all the serverless platform that run on top of Kubernetes are in fact deployments, right? Every function is a deployment, so that could be easily extended to functions. Another thing I've recently did on Flagger was instrument Flagger for Prometheus. So if you scrape Flagger, you can see in real time when it changes the traffic, if it fails a Canary release or not. So what you can do, you can use Alert Manager to be alerted if when a Canary started, if a Canary failed. Another thing I plan to do is to publish the Canary analysis logs to something like Slack or whatever other platform. So you don't have to tail the logs or do kubectl describe to see what's going on. Other questions? No? I'm good? Yeah. I think I've started when Istio was 0.6 or something like that. Before the API changed. So I went through the changing of the API, which was painful. Afterwards, last year at KubeCon in Copenhagen, I had this idea to automate, so I did a demo with Canary, manual Canary releases, right? So I had this idea, okay, I don't want to modify YAMLs all the time to increase traffic and all that. I want to automate it. And by then, there was no Go client. So I wasn't able to, talk to Istio, have all these objects. I would have to vendor the whole Istio project, which I don't want to go there, probably a nightmare. But now that Knative did all this stuff, it's easier to do automation on top of Istio because somebody did this Go client. I find it hard to debug Istio in some areas, and probably the next talk will solve that problem. Other things that I've encountered while testing each version and playing with it is, for example, the last version I had a problem. I upgraded with Helm, and everything blow up. Like the CPU was at 100%. The pilot was there. And I was, what's going on? The fact was I didn't apply manually all the CRDs. So some CRDs were missing and pilot was looking for them and say, oh, no CRD, 100% CPU. So it took me some time to detect what the hell is going on. So being, you have the Kubernetes control plane, and now you have the Istio control plane. So you have to deal with Kubernetes network. You probably use a CNI, right? And now you have another layer on top. So when something breaks, you have to look at your physical network first, afterwards the CNI network, and afterwards to the service mesh network. Just debugging networking, it's way harder when you add all these layers on top. Of course, you have lots of benefits. You can automate Canary deployments. You can see great, I don't know, dashboards. You can get open tracing. I love Istio for that, right? But it makes, I don't know, an SRE job harder when it comes to, when it breaks. When it breaks, it's hard. When it works, it's great. And at this point, I think it's easier to start with Istio and learn Istio because the documentation is great. We finally have a stable API. It will not change, hopefully. Who knows? But at the moment, yeah, the experience of using different versions is okay. Yeah.
Yeah, you just said you want the Istio API to stay stable. Do you think there's any features missing in rolling these Canary releases in terms of the API? Is there any parameterization or something missing that would help make it better, the experience of your system?
Yeah, so the first Istio version was relying on ingress controllers, right? And ingress has its own limitations. So now there is a custom resource, the Istio gateway, that replaced ingress. And you have virtual service where you can change the weights, and you also have the gateway. I think something that glues together these two under some metrics, so you can look at gateway metrics and your actual deployment metrics, a unified view of those two could be an improvement. In terms of the API, I don't think I wanted to do that. I wanted to do something and it wasn't there. There are lots of things. But yeah, it's easy to configure something wrong, and it's hard to detect when that configuration goes sideways. But yeah, there are improvements also here. Now there are validation webhooks, so when you mistype something or you, I don't know, add a weight more than 100%, you can type like 50 and 52, something like that. When you apply it, now you'll get an error and you said, no, the two weights are over 100% or lower than 100%, which is not possible, right? So yeah, there are all these improvements in the 1.0 release are really helpful to at least make it easier to get started. Yeah.
So straight out of the gate on the README, you mentioned possible breaking changes in the future. Obviously, I know it's new.
Yeah.
Perfect. How can we help you? Try it.
Yeah. So it's a V1 Alpha 1, and I've changed it like 3 times now. The custom resource definition, like 3 times in 1 week. Yeah, if you play with it, give me feedback, open issues, that will be great. Come with proposition how this Canary spec should evolve. Because I have one vision, like how I want to do Canary releases or how I want to do progressive deployment, but I bet my vision is very, very specific, right? In the future, I want to add more kinds. Like Canary is one thing, but you also want to do A/B testing or feature flagging. The main difference is, in my mind, so the Canary can be automated like this because a Canary release should not take hours or days. But if you think about A/B testing, A/B testing is something that comes from your marketing team or from the management. We want to test a new version of an application, but that new version is not a performance testing. It's more of a future testing, something you change something and you want to see will it sell better or not. How Flagger should automate that, because it will be a long-running process. I have no idea right now. I need to talk to somebody that is doing this kind of A/B testing, like is their core business, so I can understand where automation comes in and how automation can work for these other use cases. Also, another issue here is like we have deployments, but you also have stateful sets. Does it make sense to have a Canary release for a stateful set? Does it make sense to test, I don't know, a new version of the, I don't know, Postgres and route some traffic? I don't think so. But yeah, maybe there are TCP services out there that could benefit from a Canary process like that. Also, right now, everything is limited to HTTP and HTTPS. So one thing that I also want to add is gRPC, because Istio has metrics for gRPC, so that would be easy to implement for gRPC. Yeah.
So I'm not looking for video with Istio. So, but I see that you have an alternative graph there, and I'm just wondering how that difference works. Have you always reachable an alternative URL, or is it like some integration with the Grafana that's already on the
Like this one.
Can you repeat that one?
So how you build Grafana dashboards for Istio? Istio comes with 6 Grafana dashboards, I think. It comes with its own Grafana instance. And how I learned it, you just look at the queries and you see the Prometheus queries there, and you can build your own dashboards from that, or improve over what they are delivering. So
Actually in Istio and not a Flagger instance of Grafana.
this one is a Flagger instance of Grafana because I want it to be easy to install it and look at it, right? But it's just a Grafana dashboard. You could add this dashboard to the Istio Grafana distribution. You don't have to use another Grafana instance. I'm doing that because it's easier to test it and you just have it there. And again, all these metrics come from Prometheus that's being part of the Istio installation. So you don't need to set your own Prometheus or anything. Everything is set up for you. You just go there and build all these dashboards. And you have lots of examples how you can build it, what queries you can write. It's PromQL after all. It's not that hard. I don't know. I'm used to it. Yeah.
I think a lot of these canaries are assuming fairly constant traffic. You can actually observe services and react to it. Have you had any thought about like dealing with more spiky traffic, where you got nothing for a day, and suddenly your site gets hit for 1 hour, like sales of tickets as an example. At which point some of these techniques might not work that well. Like have you think of like integrating some other metrics from the test automation or something like that?
So yeah. So you have traffic spikes and how you make sure you actually do a correct canary when you have traffic, right? So one way to do it is like I'm doing it now. I'm having a load test tool that hits my application. So even if it's in production and I'm not receiving any traffic, this is not production. It's like it's a GKE cluster on my own. I'm simulating traffic, but I think Canary has a real value when you have real traffic. It's pretty hard to simulate real traffic. One way to do it will be with Istio to mirror the traffic from one day, store it somewhere, and afterwards replay it. Yeah, maybe it's an Istio goal for the next years. Replaying traffic is something very hard. But besides that, you can, for example, you can play here with So you can play here with these values. When you install Flagger, you tell it how often will it run the control loop. Now, because I'm doing a demo, it's at 10 seconds. You should not do that. You should wait 1 minute between rollouts, so it has some kind of data in Prometheus to take all these decisions. But you can increase the control loop period. Let's say you can increase the control loop period to half an hour. So each time it advances, it will look at the last half hour of data. And that's more conclusive for your application, right? And here you can say step weight 1% and max weight, I don't know, 100%. That could take like half a day to do the Canary deployment, and you will capture more traffic in your production. Playing with these two values and the control loop, you can increase the time. You can make the Canary rollout slower or faster. It's up to you how you want to orchestrate that. I don't know, in your case, when you have spikes, if those spikes happen every day, maybe you want to time your deployments to hit those spikes so you can get data. If you have a spike every month, accept recording the traffic and replay it. I don't know any solution out there, but yeah, it's a great question. Yes?
Yeah, what happens if you've got one release in progress and then you deploy another release that has another canary? Will the first one just stop, or does it queue them up and wait for the first one to go all the way through?
So you have, yeah, I will repeat the question. So you are doing a Canary release for V1 and it didn't finish, and at some point you make a new deployment, 1.1, let's say, right? What Flagger does now, it waits for 1.1 to do the rollover, so it holds, it doesn't increase the traffic, and continues with the Canary. It doesn't go back to 5%. And I was thinking maybe I could add some kind of flag or option in your Canary spec. Maybe you want to reverse it and start from scratch. But I think if you notice something, you'll ship a patch very fast, and you don't want to start from zero. You want to continue from where you were before. This is what it does today. So it waits for that new version to be rolled out, and it continues the Canary analysis as it is. Yes?
So I know I always bang on about the testing aspect, but kind of in relation to the spiky load, hypothetically, if you were to deploy a job pod along with that main bulk of the deployment that contains some form of like non-destructive smoke tests that was hitting your application and forcing some sort of load, you could do something quite fruity, I guess, where you then expose something that was scrapable, that would return success of those jobs, that you could then have as a custom metric to determine whether or not your sort of meta tests that the deployed passed. Again, there's quite a lot of interaction there, and you might be better off just actually having a build server that's initiating those tests. But then there's some benefits for running them inside the cluster, perhaps. But yeah, there's kind of, I know we were talking about how
Yeah.
to force this testing in as part of the deployment cycle.
Yeah, so one idea will be when you create this kind of definition, you'll have an area here where you can specify jobs. You'll say, I want to run all these jobs before the Canary analysis starts. And those jobs could be load tests, could be, I don't know, security tests, whatever. And if those are scraped by Prometheus, and you can do this kind of easy, and if Flagger will have the custom metric support, you can take decisions not only on the performance metric, but also on your load test results or security test results and so on. But you can use Flagger, let's say, potentially to spin up those jobs for you, but of course you can do this thing from your CI. And once the deployment has been rolled out, you also deploy in parallel all these jobs on the cluster. If they expose metrics, yeah, theoretically you can get decisions based on that. Yeah.
See this as a lighter weight Spinnaker Canary deployment system, or how does it compare to Spinnaker's?
Yeah, so Netflix has a different approach. They don't look at the primary metrics like I'm doing here. They will spin up the Canary instance, and they will do a clone of what you have in production, and they will spin another deployment. So instead of I'm having two deployments, one that's your production version and one that's the Canary. How Spinnaker does it, it looks at the production system, it creates a clone of it, and you'll have 3 deployments running. Yeah, I wanted to implement that, but I feel like for the first implementation, that sounds expensive because you'll be running 3 things instead of just 2, and I think this is the minimum requirement to run a Canary deployment. If you want to have all this stuff, yeah. Yeah, Flagger at some point could do that. Yeah. And there is another difference between what Flagger does in terms of the Canary analysis and what Spinnaker does. So in Spinnaker, you will not set these thresholds for the Canary. You'll say it's a delta between your production workload, the clone of the production, and the Canary, right? Yeah, it's a different approach. In my mind, I want to set some thresholds. It doesn't matter. Maybe my current production system sucks. So I don't want to look at the delta. I'm setting some thresholds for what I strive at, what I want how I want to validate my Canary. But for some systems, it makes a lot of sense to look at the delta and not have these thresholds hard-coded here.
I'll ask one more. I was thinking, like, have you considered writing this as a client utility versus like the operator approach? If so, why did you choose the operator? Is it like part of the GitOps philosophy?
Yeah. So why is Flagger an operator and why is not just the CLI that you run? First thing, having this outside the cluster will, in my mind, will be harder because you have to reach the cluster through something. You have to open your cluster to whatever is there, your CI system and stuff like that. So you have to somehow expose kubeAPI outside the cluster. If you're running Flagger inside the cluster, you don't have to expose any kind of keys. It's there. That's one concern. And the second concern is the fact that if you're running it outside and it crashes, I'm relying on Kubernetes to, oh, Flagger crashed. Okay, I'll spin it up on a new node. So you have HA, you have all these things that Kubernetes offers. So that's why I went with the operator approach. Yeah.
One pattern question. In the workflow or the process flow before you release, you bring up Canary pair alongside the production pair, and then when the load passes, you then rolling release your existing production pair and destroy the Canary pair. Is there any reason you didn't just scale down the production pair and make the Canary pair the production pair?
Yeah. So why? Yeah. Let's think about it. Short. Yeah. So why I'm scaling down the Canary? I'm not scaling down the primary, how I call it, the production workload.
Yeah.
Yeah. One reason for that is, for example, in a GitOps pipeline, you continuously apply the Canary, right? You have that in Git, is the new version, that continuously apply. If I am modifying it and I'm keeping it at 100% and I'm killing the production, when you modify that in Git, you'll override your production workload. And I want to avoid that. So V1 is not in Git declared. It's owned by Flagger, and first time when you do the first deployment, there is no Canary to be run. It just does a clone and scales down the Canary. When you push something to Git or you do a kubectl apply of your new version, then Flagger will scale it out. This is how I'm avoiding a conflict between desired state and actual state in the cluster. Yes?
So, on the subject of GitOps, how would you theoretically use this to promote between flux? Say you've got develop dash star, this is rolled out V2. Would you put a job in, custom job in,
So can you use something in the Canary process for promotions, right? Yeah, you can, for example, how I imagine it, you have your staging cluster, you deploy there the Canary, let's say you have a load test, it goes okay, you have another thing that reacts to that event. Let's say alert manager can call some CI API you are having, and that
Run the integration tests and then tags.
and create a new tag. So and here in the deployment spec, for example, you could enable automation. So here I can say I want this workload to be automated, and I want to automate only for patch releases. So if I'm pushing to the Docker Hub or whatever container registry you have, 143.2, create the automated Canary release and try it out. So if right now I'm on 3.1, and if I'm committing this change, what Flux will do will look at the Docker registry and will see, oh, there is a new version than this one, and it will modify this file and it will push it to the cluster. So if we look now at the commits, come on. Yeah, I think it's set as at 5 minutes or something like that to check for new. Yeah. Yeah, I should have set it lower. But the idea is you can automate patch releases, and I think it's safe to do that. But when you are doing a major release, you definitely want to have control over that. So I think having something like an alert manager that calls a hook, that everything on your staging cluster is okay, only then trigger your production Canary. So,
Flexibility either way in each
yeah. Yeah, and also because Flagger talks to Kube API and creates all these events, you can also automate it from inside your cluster. You'll look up for Flagger events. It's kind of easy to do that with the Kubernetes Go client, and you can take decisions based on those events. Oh, the event was okay, the Canary on staging was successful, do something, retag that, or trigger something in your next pipeline step on your production cluster or whatever else is there. Yeah, it doesn't work. Mhm. Other questions? No? Thank you very much. Thanks.
Thank you very much, Stefan. We're going to take about 5 minutes, 10 minutes break now, and then Leon's going to come on. So, but yeah, put your hands together once again for Stefan. As really looking forward to using that.
Right, we will recommence very shortly. Please take your seats. Is that okay for you?
Yeah, I'm going to be on this side, so that's fine.
Right, our next talk is by Liam White from Tetrate. He's going to be going into the nuts and bolts of Istio networking and leading us with a treasure map which to follow to identify problems with our clusters. He assures me that he is leaving the country directly after this talk and to address all complaints to Dev Null. Liam, to you, my friend.
Thank you. Okay, so, get a bit closer. So my name's Liam White, like I said, software engineer at Tetrate. My talk is going to be about, there's plenty of talks on kind of debugging your applications with Istio, but this talk's more of a debugging Istio talk. So, it's a bit by me. I'm a software engineer at Tetrate. Like I said, we are a service mesh company. We've got some announcements coming soon around, there'll be some stuff around EnvoyCon and that type of thing, so keeping an eye out for that. But we're working kind of in the service mesh area, trying to make the experience of using service meshes a bit easier. I am a core contributor to Istio. I've been working on Istio for about 2 years. I started when I was working at IBM. Obviously, it's a joint IBM-Google project originally, so I've kind of been working on it before it was even announced, I think at GlueCon, whenever it was officially announced to the world. Specifically, I work on the networking and CLI side of things, and I'm a core contributor to those things. I've been looking at the debugging experience because while I was doing dev work, I was struggling to debug it, so obviously there's an issue if while I'm, as a dev, doing dev work on it, there's going to be an issue of users doing it. So address all your debugging complaints to me, and I will write them down somewhere and then work through the list. Yeah. So the aim of this talk is to kind of go into detail a bit more about how Istio works. It's debugging to teach you how to kind of understand how Istio works under the covers a bit. It's going to be a bit of command line, a bit of diagrams to kind of give some context and some background on what's happening, and plenty, and a couple actually of SpongeBob GIFs, because that's, we need to, debugging is quite like a detailed topic. If we're going into detail, we need to kind of lighten the mood at some point. So we're going to be debugging Istio on Kube. This will hopefully be interactive. I don't know how familiar you all are with Istio. I will have some stickers as prizes if anyone can guess what's broken based on kind of my nudging in the general direction. I think I have some Istio ones and one Envoy one, so first person gets to pick that one, I guess. So, like I said, I'm going to flip between slides, flip between terminal, give a bit of background, and with that, we'll kind of get on with it. So, for the 5 people in this room who probably have never seen book info before, because I've seen probably 30 talks using book info, so we're going to use book info. But this is kind of the demo app you get with Istio. We have Envoy running at Ingress. We have sidecar envoys running everywhere, multi-language. I'm not going to care too much about the actual traffic routing. We have all 3 versions of the reviews in there, but we're not going to care much about that. And yeah, we're going to kind of look at the state of book info. So, what tools do we have to debug Istio at the moment? I'm only going to use command line tools today. We do eventually want to move all this actually to the dashboard itself, like into dashboards. There's work going on in Kiali to try and surface some of this information in dashboards, because in production you don't really want to be using command line tools to debug your stuff. But for now, kind of these tools only exist within the command line. So the 2 at the bottom you're probably quite familiar with, kubectl and Stern is kind of a wrapper around kube logs. It allows you to kind of wildcard across multiple pods and that type of thing, and nicely tail things and that, or trail things. And then these two commands at the top were new in 1.0. So proxy status gives you the kind of status of your overall mesh. So what it actually tells you is the synchronization status between all of your envoys that are connected to Pilot. And we'll dump out that all information to you and merge it all nicely if you've got like, multiple instances of Pilot. And then we've got proxy config. And proxy config allows you to, once you've identified using something like proxy status to work out which Envoy is actually causing issues, it allows you to then deep dive into the Envoy configuration itself to work out and kind of look through that and work that out. And hopefully I'm gonna be able to explain how to map that Envoy config back up to Istio config, so you can identify maybe where you've configured something wrong. So this is what book info looks like currently. If I quickly tab over here, so product page is working. It doesn't actually seem to be able to talk to any of the other microservices there. So what actually has happened here, as far as we can see, is this, right? We can see the product page. We can see we're hitting the product page because we can see that, but when it makes downstream calls, it doesn't seem to be able to make any of them. So does anyone have any I'm assuming you can all see my command line. That's fine at the back? Good. Okay, does anyone have, really open-ended, any suggestions on where you would start debugging this? Bearing in mind we're in kube.
So minus tail 10, somewhere next to it.
For the pods, okay? So if we go and look, so one of the broken ones, so let's do rating, it doesn't matter actually, does it? Minus 10 seconds. Okay, so that's pretty clear already what's happening there. This is running the 1.1 snapshot. I can't remember if this is in 1.0. Actually, we'll stop there because that log line's relevant. So what this is saying here is we added a readiness probe, and this is to prevent, we had some sporadic 503s where if your Golang application would be ready to serve requests actually before Envoy was ready and had all the config loaded in. So this here is basically us doing a readiness probe into Envoy, and Envoy is saying, actually, I expect to be able to serve traffic based on your kube service specification. I think it might be the container. Actually. I'm unable to serve traffic on 9080. I expect to be able to serve traffic on 9080, so I'm not ready to serve traffic. The reason it can't serve traffic is actually this logline here. Does anyone know for a prize what that logline means? But what does that mean in terms of Istio and Pilot? Okay, so what this basically means here is, and I'll get some diagrams up in a minute to kind of give some background, but this basically means that Envoy can't actually connect to Pilot, right? Envoy, if we go back to the charts quickly, Envoy uses dynamic config, and this is different to most proxies. Proxies like Nginx use static config, right? You generate the nginx.conf file, you load it into Nginx, it runs based on that Nginx config file. But with dynamic proxies, such as Envoy, you get all your config from the API, and that's what Pilot is actually doing, right? Pilot's just exposing a set of APIs based on what you've told it and what kube has told it if you're running on kube, Envoy is basically streaming that information down from Pilot. Now, the reason that this design decision was made with Envoy, and we're seeing it a lot more in kind of the cloud native area, is that it's designed to handle ephemeral config natively, right? So we don't yet use it in Istio or leverage it in Istio, but potentially you could just send diffs down, right? So whenever a pod spins up, you don't need to regenerate an entire config. You just send down the new pod IP and port endpoint that's come up. So to quickly illustrate what I just described and kind of go into where this is actually broken, Envoy, when it starts up, opens up a two-way gRPC stream. This is kind of what we've experienced, right? Some of our things can't connect. Presumably, some of our other things can connect. Because this goes over a network, this is now a point of failure, right? You would, technically, if you're using an Nginx ingress controller and it can't talk to the API server, that would also be exactly the same point of failure. But because each of the envoys need to be configured, they need to be able to reach Pilot in the first place. Now, the reason this one is broken is because I've been a good kube admin and I have added network policies. However, I've forgotten to add an egress policy so that it can speak to Pilot. There are other ways you could get this to happen, but none of which are reliable to repro in a demo. So I've got a slightly hacky way of going about this and a bit obvious. So what's happened here is I've got front-end policy for product page, right? And I've said that can speak to Pilot, but I've got a back-end kube network policy that's basically blocking all egress to Pilot. Now, if I quickly go back, if you see something like this and you see multiple things potentially on the floor, the best way to debug this, and quickly I've aliased I to istioctl because I'm very lazy. I also wrote this command, so I did PS rather than proxy status because I'm extremely lazy. But what we can see here is this is the list. I will get this all on one line, so it's actually readable. This is the list of all proxies in your mesh that are connected to all pilots that we could reach in kube. So what we can see here is the egress and ingress gateway pods are connected. We're not using egress, so it doesn't really matter. But product page is still connected. And they're all in sync, but all of our other applications are actually missing from this. So if I quickly do some makefile-driven demos, if I run makefix1, all I'm going to do is patch the backend network policy so it can fix it. And we'll see that populate in a sec. So now all these envoys, hopefully they haven't gone into backoffs for too long. We've already got some connecting here, right? So I'll go into detail a bit later on what the CDS, LDS, EDS, and RDS stuff means. It basically, these are the 4 APIs that Envoy, it doesn't expect you to implement all of them, but these are the 4 total ones that you can implement within Envoy. So we'll just check that these are all in sync. Okay, right, so this is all now in sync, so theoretically, I should be able to load up product page. Great. So we'll just refresh so we get a rating service that's actually showing stars, and we've successfully fixed that. So the key here is using proxy status to kind of look at the wide berth of what's going wrong in your mesh, and this will pick up potentially any configuration errors. I will go quickly into detail about things that you might see in proxy status. So we saw stuff missing. Missing means it hasn't connected at all. It's not currently connected to Pilot, so it's never going to work. It's just got no config. Synced is good. Synced obviously means that everything is in sync. The 100% is the amount of endpoints we load in. This should always be 100% as far as I know. I don't know if we've changed that recently, but this should be 100%. Not sent is actually also fine. Not sent means Pilot hasn't got anything to send the envoy, so it just hasn't bothered to send anything, so that's fine. And then we have a couple of stales here. Now, it's hard to repro a stale without being extremely hacky. So the reason you can get stale here is, first of all, there's a timing window, right? So if you hit Pilot, what stale's actually showing here is Pilot has sent some configuration down to the envoys, and the envoys are yet to actually acknowledge and send an ACK back to Pilot to say, I've successfully received and processed your configuration. So there's a timing window here, right? If you happen to hit the Pilot at the millisecond it sends it out, then potentially you will be stale. There's a PR open at the moment, I think, to tell you how stale it is. But that should get into 1.1, but we'll see. Yeah, so that's the one issue there. There's also network latency issues. So if your network is saturated and it's taking forever for the request to get there and back, you're going to see stale. You've probably got more pressing issues if that's the issue. Your entire network will be on the floor at that point. The second one, which is actually the other way you would repro this consistently, is there's a bug in Istio itself. The reason it might be stale is because we've tried to send config to Envoy that's not valid Envoy config. Now, that's a bug with Istio. You should raise an issue. It's difficult to get a repro of this in a demo because it gets fixed pretty quickly. So as soon as I do it, it gets fixed. But you can go in the logs, and if you look at the logs of the proxy itself, you'll actually see Envoy saying explicitly, I've rejected this config for this reason. There's another thing you can use with proxy status, where if you give proxy status the pod name, it will actually tell you a diff between what pilot says the proxy should look like and what the proxy actually looks like. So you can quickly go into that and see, oh, it's rejected this cluster. I'll go into detailing what a cluster is in a minute, but it's rejected this part of the config, and go ahead and either raise an issue or work out what exactly has happened in this situation. It's kind of a difficult thing to actually go into. I'd just suggest raising an issue over that. So the third and final one actually is something we used to see with large-scale deployments before we moved to the Envoy v2 APIs. So there's a chance that if you've got quite a large Kubernetes cluster and stuff's coming up and down all over the place, Pilot can't physically keep up with all the configuration changes and push all of those out. Now, you might see stale in this case. The way to fix it, you would be able to identify that by the CPU profile in the Grafana dashboards. I'm not going to go into that because that's a whole separate topic in the dashboards themselves. But you'll see the CPU basically at 100% or near 100%. You should scale up Envoy instances. Pilot instances. Pilots are stateless. The only state they have is the specific envoys that are actually connected to them. And the envoys don't care which one they're actually connected to. So we fixed one thing. This is actually how I feel debugging some stuff sometimes. You kind of fix one thing, try again, see if it works. Keep fixing stuff until stuff works. So let's see if we can work out what the second issue is. So that's obviously given it away a bit. If I go to which order are we in? Here. So if I go and sign in with bookinfo super secure clear text sessions, we get an error. So this error here is specifically notable because it's a 404, right? 503s are a different animal for a separate talk. But this one here is specifically a 404. So if you were kind of trying to debug bookinfo, where would you go about starting for this? No dashboards. That's a separate talk. Okay, so yes, that is the correct answer, actually. So I'll go through and get to that because I teach some background to get there. But potentially, if you didn't know much about Istio, you would go and look at the logs, right? So if I go and look at product page, I can't see that login request here, right? I don't know what the time is exactly now, but 27, right? There is no log here, so we know it's not getting to product page, right? We know that's the issue. So if I go and look at the ingress logs, so go -n. We can see the post login here, and this is the key point. We get from Envoy logs, we get 404 NR. Now, NR means no root, basically. So we know we've identified that this was wrong, but what does no root actually mean, right? There's a couple of Envoy flags actually that are quite useful that you probably all should know. I put a link to those, or I can send you over to those in the end, but I think there's about 10 that are all pretty useful, that are all useful for identifying actually what's wrong. But this one specifically is no root. So we'll go back in here. Can't get to login, can get to product page. We're creating the request to get login. And what's basically happening is that the ingress gateway is saying, you've made a request. I don't really know what that means. So you can go in and look at the Envoy config to work this out. Now, you correctly identified that it was a virtual service issue. But if you're going to identify this in Envoy config itself, how does Envoy actually decide where to send stuff, right? So here we're making a request. This isn't the same ingress gateway. This is just like an app running in bookinfo talking to the review service. It's making an HTTP GET request to book/1. The host is reviews.whatever.default.service.cluster.local, and the user agent is Android. Now, at this stage, we happen to be running a Canary deploy just because it makes it a bit more interesting, where we're not doing traffic percentages, we're using Android users specifically. So we're just saying route all Android users to v2 rather than v1. So how does that work? The application actually goes and makes this request. We do an IP table redirect through to a physical listener. That's the LDS in that proxy status you saw. The physical listener, there's always one listening on port 15,001. That's how we know to reroute the IP tables or the request using IP tables correctly. That then hands it off to a virtual listener. And this is all Envoy config specifically, so it hands it off to a virtual listener. That virtual listener will always match the port that the initial request came in. That listener then, because it's on port 9080, knows it needs to hand it to the route 9080. This is the Envoy specific route. Within the route, there's Envoy basically asks a load of questions, right? It says, what host are you using? What prefix are you using? And in this case, the relevant one is what user agent are you using? And because the user agent upstream was set to Android, that's propagated through, and then Envoy says, oh, because you're using, because you're making this specific request with this specific user agent, I know I need to send you onto the v2 cluster in Envoy. And it will look something like this. It will be an outbound request because it's going from the app out to another app outside of the pod itself. It's on port 9080, so that's that part. The v2 is because we've told Envoy to say any Android users send them to v2, please. And reviews is just the service that's sending there. So v2 is the subset in terms of virtual service, and reviews is the overarching, this is the reviews Kubernetes service that's sat with multiple versions behind it. So within a cluster, there's multiple endpoints. In this case, we've got two. We've got the bottom two there are running v2. So those are the two endpoints that are part of this cluster. So Envoy will then just pick one based on certain policies you set, and it will go ahead and forward that request on. So the issue here was no route, right? That means that it can't really get from, it can't work out how to get from that listener down to the cluster itself. The questions it asked, the answers you gave, it was unable to identify where it needed to send you. So how do we fix this? We already know the answer is virtual service, but let's pretend we don't know that answer for now. So destination rules are specifically responsible for basically this part of the Envoy config. The exact definition in the kube docs is they define policies that apply to traffic intended for a service after routing has occurred. And they'll do things like, for outlier detection, the destination rules will define which endpoints need to be ejected. So whatever outlier detection you have on latency or error rates, their response, you define it in there for booting it out of that cluster endpoint pool. It'll do things like connection pool settings, so simultaneous connections to a single endpoint. You can limit things like that. But that's the scope for destination rule. Now, we know we were never getting to that cluster. So we know that that's not what's wrong and not what we need to fix. What we do need to fix, as correctly identified, was the virtual service. So again, the virtual service official definition defines a set of traffic routing rules to apply when a host is addressed. But what that really means in Istio terms and in Istio on Envoy terms is getting from that listener, so from that port, looking at all of the HTTP headers, so host, prefix, user agent, whatever kind of HTTP header matching or path matching or whatever matching you have in there, and correctly identifying the cluster that it needs to send to. So if we go and have a quick look in the command line, let's get rid of Stern. If we go and look in, where do I need to look? I need to look in ingress. So we have proxy config, again, you can do PC. We want to look at the root in particular. So if we go and look at the root, and we need to look Istio system because it's ingress. Help if I use the correct namespace name. And we need to look in the Istio ingress pod. So here we've got a bunch of routes. This is basically all the routes that are available if you went through the front door. So we do have some dashboards available there. I've not actually verified that they are correctly exposed, so we can't look at those. But the interesting one here is because we're making that HTTP request on the way in on port 80, because book info is super secure. And we want to filter by name, so we'll do http.80. And we want to output in JSON so we can actually go and look into some of this information. So if you saw no root and you actually went to go and look in that proxy itself, you could just look at the roots like this. So this is a lot of JSON, but what's basically happening here is we have this single root. It's matching on virtual host for everything all the hosts coming in and everything coming in on port 80. And we're doing a match here. This is Envoy config, so it's very verbose. But we've got a match here. This is specific path for product page. So this is how product page is working. It's matching it to this specific cluster here, the outbound 9080. So that's correctly sending it to product page. And here we've got logout, and that's going through to same thing. So presumably logout works. And we have a prefix match on this one. Now you also might see user agent matches here. Again, whatever you're configuring virtual services, that's what's going to be there. So we don't have here login, right? So that's obviously why it's not working. Now, I've intentionally gone with simple examples so I can kind of explain the broader concepts, but the idea here is to understand the underlying concepts, work out where you go and look for these type of things, and then go and solve it. So again, if I do make fix2.diff, all I've done is simply added this root into a virtual host. It'll get pretty quickly propagated. So if I fix that and run that same command again, trusting the pilot's added it in that quickly. Right, we've got this login match here now on, we've got this match on path of /login, and it's now routing to product page. So hopefully, I'm going the wrong direction. Let's not retry and resend stuff, because that never works. Wait, it's all fixed. Okay, so, and hopefully sign out works, because that root was there. And it only talks to product page, because it's super secure. And it's so secure that it doesn't store any credentials anywhere or validate them. So, there is probably a separate slide I could do here on gate. I found this quite useful, trying to think through exactly what this maps to in Envoy config. Now, in Istio, at some point, you will, if you're debugging networking stuff specifically, have to read Envoy config. There's no getting around it. So it's important to understand the kind of interactions between listeners, routes, and clusters, and then endpoints. We have command line tools to get into all of those if you want to go and see them. It'll summarize them, and then you can read JSON to your heart's delight of all of the Envoy config. But yeah, there's probably a separate slide, like I said, I could do on this on gateways and, again, completely blanking up here. Gateways, so gateways are the physical listeners, so you define gateways, and they will define physical listeners that are listening. So in Ingress, for instance, they'll have a physical listener actually listening on that port as well. And then service entries are for virtual listeners. So the things we forward to, service entries define those. But that's a whole other ballgame. Focus on this one now. So product page is fixed. SpongeBob's happy. And that is the end of my talk. So quickly, we know the debugging experience in Istio is not where it should be. This was kind of just command line level and a very tiny, simple example. And there's still a lot to take on there, right? So that's kind of why I kept it there. I'm interested in finding out, probably offline and not everyone shout at me at once, exactly where the issue is, or the issues you're having with debugging and what you want to be able to see more of. But come grab me at the end, DM me on Twitter, my DMs are open, or actually raise an issue and specifically tag me on GitHub. I'm Liam A. White on GitHub. It was taken on Twitter. So yeah, any debugging experiences and horror stories, happy to hear them because we want to improve. And I will take any kind of non-statementy requests as questions, please. I can also answer API questions-ish, as long as they're networking. Yeah.
We'd like to make Istio core to our product. We've got a bunch of HTTP traffic
So this is actually an interesting question. So for those familiar with HTTP 3 and the spec for that, it needs UDP. So the reason we don't support UDP is purely because Envoy doesn't support it yet. There is work currently going on and has been going on for a while to support UDP in Envoy, and as soon as that's supported, then I'm sure we will pick it up in Istio. But there's obviously some people who are working on the Istio team that also work on Envoy stuff, and they're kind of pushing that type of stuff within IBM and Google. But until it's in Envoy, Istio can't support it, right? Because Envoy doesn't understand it yet. There's an issue that's currently being worked on, and I know that I think it is probably Matt Klein tweeted out basically as soon as HTTP 3 was mentioned, like as specifically now a thing that's going to use UDP, that they really need to do it. So yeah, the work's ongoing for that.
Just a quick question, I don't know if might be relevant, but like that's one of the ways that you use the broadcast is that we have access to the logs. And I'm just wondering, if you are deploying a cluster alongside Istio, what's your recommendation, or how do you do it for production? Because between logging, with the type of the FAA, one-sided service provider.
So the question was, how would you manage logs basically in Istio in order to be able to do it in production where you don't have to have command line access into the logs? Is that the question? Yes. So it depends on what you're using. So what we were looking at there was specifically Envoy logs, right? There are two ways you can actually get logs in Istio. You can talk to Envoy and ask it directly, or you can go to Mixer and you can configure logs through Mixer. So it kind of depends on what your traffic profile is. If you have, basically Lyft don't run Envoy access logs in production as far as I know, because it basically takes too much performance hit doing the file I/O basically. So what we do in Mixer, which is kind of asynchronous, is we batch up all of the requests coming in, and then we'll, in one big go, dump it in Mixer. And you can then tell Mixer you can configure it to talk to whatever adapters. I can't remember which ones have actually been implemented so far, but you can basically use Mixer to either dump it to standard out and then scrape Mixer standard out, or you can get Mixer to basically plug in directly with your logging service if they've written an adapter for that type of thing. And that's what I would use in that case. And you can use the default ones, or you can, as long as Envoy has a stat for it, you can basically add it to an access log line. As far as I know, you just have to configure it. Now, don't ask me how to configure it, because I don't work on Mixer stuff. I just use the defaults. But there's some pretty powerful stuff you can get in there if you really want to get at it, basically. Say that again, sorry? So you were talking about like the Envoy in particular? Oop, go back. So in here or in the command line stuff? I'm not sure I understand the question. That's what I'm trying to. That comes from Envoy itself. So that's us specifically. We basically, because we need to do it securely, we have to piggyback on top of Kube's authentication. We exec in, and then we run a command that's specifically pointed at Envoy's admin API. So all of this comes out of Envoy's admin API itself, and then we just parse it basically into some JSON that's readable-ish. So into product page, yeah. So if you were to deploy book info, normally it would just look how it is fixed, right? This is all config in Envoy itself. Obviously, you tell Pilot what to tell Envoy, right? Similar to how you tell Kube API server what to tell the kubelets. But yeah, or if you were to deploy book info like this, like it's in the actual like demo apps, it would look exactly like this. I specifically went out and removed the /login just so I could break it intentionally. Obviously, don't do that if you are running it. Does that answer your question?
Yeah, so I was just wanted to check, because if you could have done it externally and it could have been forwarding traffic into a Kubernetes
Yeah. So that was. Yeah, so that's kind of the second hop after the ingress, right? So it goes ingress, product page, and then all the downstream services. So yeah, you could, if you exposed a gateway and pointed the gateway at a virtual service that pointed at product page, you could expose it, but then you're still going to use an ingress gateway basically at that point. Anytime you enter the mesh at least, because the kube ingress definitions itself was deprecated in Istio, because everyone's kind of started to move away from kube ingress because you have to basically hack it in annotations to get it to do what you want it to do, normal kube ingress. There's been kind of a breakaway from that model, and that's why we specifically separated the gateway stuff and the virtual service. So the gateway stuff is exposing layer 3 concerns, exposing ports to the wider internet, and then the virtual service hooks into the gateway and does the layer 7 actual ingress stuff rather than the layer 3 ingress stuff. Actually, I'll go around because you've already had one.
So I was going to ask, when you run the Istio CTL commands, is that showing what is or what should be?
That's showing what is currently in the pod that you pointed at.
Okay. So if you were to look at what you've defined in your virtual service, for instance, that's what you want, and this would actually show if it's actually made it in as it should be.
Yes, and you can also do, proxy status without actually passing anything in. So if I do this is going to tell me it's all in sync, hopefully. Unable to pass. Okay, because I need to do. This is also fixed in a recent PR. I remember merging it. So what this is saying here is this is actually doing a diff. So it's going to a pilot and saying, if I was this Envoy instance, what would you give me? And it's also going to the Envoy instance and saying, what have you got? And then it's basically just doing a diff of the two. Now this all matches, so it's not very interesting, but if you're missing stuff in there that is basically out of sync, that will tell you what that difference is. It's just quite difficult to replicate that consistently in a demo, so I don't do it. That is not really my realm. Come speak to me afterwards. I can ask the question. I know who to ask. I don't know how to answer the question. So come speak to me afterwards, and I'll get in touch or put you in touch with a person who can probably answer that.
So I wanted to ask, thanks for the talk. Any experience and/or opinions on multi-cluster Istio setup?
I would ask, where's he gone? Matt. So I joined Tetrate literally last week, and we're looking at multi-cluster stuff, and Matt did a multi-cluster demo at the last meetup. So he can probably answer those questions. About multi-cluster support. I don't know if you want to.
Any experience or opinions about multi-clusters?
So in Istio in general,
Yeah, Istio.
it's a big topic. There is a set of materials. I don't want to make it a thing. We shouldn't stay all night. Yeah, so multi-cluster is a big topic. There's docs on the website and a bunch of materials for using one Istio control plane with several meshes. So assuming you're in N Kubernetes clusters, you'd have one control plane and one kube cluster. That's not my preferred way of doing it. There's a few downsides, not least the latency for all the remote envoys into that control plane, but also the fact that you have to VPN your layer 3 networks together. So all your kube overlay networks all need to be in one layer 3 domain. They need to be able to route to each other. So we don't like that. So what I presented last time was a way of having multiple meshes and just getting them to talk to each other. So basically setting up routing
right? Literally having each layer 3 domain be separate, and then at layer 7, setting up inter-networking so that one service in one cluster can use a name like foo.global, and it will find the service in another cluster, and the control planes are completely isolated. They don't even try to synchronize with each other, so you don't build a horrible distributed system. That's possible today, but the networking APIs are quite complicated, so for every service you need about 5 plus 2n kind of configuration files to do it. So I've written a tool that will auto-generate those. So you give a simple definition of what your services look like and where they live, and then this thing will spit out the config and play it in. So those are the kind of two competing things at the moment, I guess. Yes, the video, the slides are available. The video's still being produced. I think I suspect the video actually is not going to be forthcoming, sadly, but the slides are up. I'll make sure it's on our Meetup page, and we'll tweet it again. Because we've been waiting for the video, but I think it maybe got black holed, so. Dev and old, exactly.
Any more questions?
Did I win a sticker?
Yes, you can have. Come see me in a bit. Any other questions? Okay, thank you. Now,
Actually, just one.
4.
How many people are you aware of that are actually running Istio in production today? Aside from our friend over there.
And how many times have you been asked?
Yeah, probably about the same number. So, I know of people using Istio in parts of production. I don't know of anyone who is full Istio. And I probably wouldn't recommend that either. That I've played around with it in dev and stage environments when I was working on my previous team. And like, I knew what I was doing, so it was all right. I've now left, and some of them are here and hit to wave pitchforks at me because there's been some issues with it. The problem. If you know what you're doing, you can use it in parts of production, if you really know what you're doing. Otherwise, you need to sit it in a dev environment, basically, and play around with it until you are confident that you know what you're doing. Because you can, you can basically screw up your networking quite easily if you don't know what you're doing. And that's always going to be the issue in any service mesh, because it's literally on every network connection. Right, that's a fundamental thing with all service meshes. Now, it might propagate quicker in certain service meshes than others, based on maybe dynamic APIs. So my advice to anyone kind of trying to get it into production is put it in your dev environment. First, identify why you need it. If you need it for mutual TLS, I would still turn metrics on, because the metric stuff's really nice and consistent. I would basically originally just ignore the traffic routing stuff. I would do metrics, get that running, get comfortable with metrics. Maybe once you're comfortable with that, push it through, pick up another feature, maybe you need mutual TLS. Mutual TLS is not that much different as long as you're using Istio ingress gateways. I would get comfortable with that feature, push it through. It's all about identifying why you're actually using it. Don't just use Istio for the sake of using Istio, because it is another layer of complexity, right? And identify your use case, get comfortable with it, push it to prod, and rinse and repeat until you have all the features in Istio that you need. And if you find that, I don't know, I wouldn't really advise, and I don't think Control Plane either would advise, writing your own PKI. But the mutual TLS stuff in Istio is one of the reasons my old team needed it, right? Because we don't want to have to write our own PKI. We don't have to want to rotate certificates, right? It's a nightmare writing all that stuff. And we don't have the skills to write that stuff. We would screw that up if we tried to do that. So I keep repeating this. Identify what the features you need, turn those features on in dev, get comfortable, push it through.
So it's more configuration rather than stability.
Yeah, now Mixer's probably a separate question. I have my suspicions. This might be me, like, because I don't work on Mixer, like I don't fully understand it. I mean, I understand it, but like there are some weird 503, like a lot of intermittent 503s you'll sometimes see with Mixer. I would not advise using policy enforcement as your first use case for Istio. I would take metrics, and if you need it mutual TLS, get comfortable with it and go from there.
We started just steps like you're saying for us. The key was just to deploy as local as possible, so our entire environment is triggered off Ansible builds from the bare metal up. So we're just like building new Kubernetes environments on bare metal, get used to it, tear it down, build another one, tear it down, build another one, get the building Kubernetes into CI/CD, get developers used to actually building Kubernetes and installing the services on your own application. Then you see the knowledge and slowly like work up, but it takes a while. And you have to kind of convince developers to start
Yeah.
taking on network tasks that they don't really want to do. So it's like a cultural thing. You have to show like you can get all these fixed requirements if you just learn a bit of tech.
Yeah.
And then you don't have to worry about all these fixed requirements because you can drag it away into service.
Yeah. And eventually that'll move further up, like Flagger, for instance, right? You get all of the Canary deploys with that, and you don't really have to, you would have to understand running Istio in production, but you don't really have to understand like how to do the Canaries. You kind of just define that CRD and it will manage it for you. Eventually you'll see, like, I personally wouldn't want to, I know you said you do, I wouldn't want to manage my own kube cluster. I wouldn't want to have to deploy it. I would always use an as a service offering, and eventually Istio will be at the point. I know, well, I don't know, I'm pretty confident Google are working on it. There's talk on IBM's kube offering as well of us working on it. But eventually it will be as a service, like a lot of kube services are. You won't necessarily have to understand a lot of this. There's a lot of work going on at the moment for the in an Istio CNI, which will move the init container injections IP table messing around. Basically run that as a CNI plugin alongside the kubelet, so you don't have to escalate privileges to rewrite IP tables in your application layer. So a lot of this will start moving down and being obscured, and a lot of the ongoing networking stuff in particular is about basically building it more into the platform itself rather than having you have to do this in your YAML, because if you look at an Istio YAML, it's pretty chatty. And we want to kind of reduce that complexity, and we want to move a lot of it just further down so you don't have to worry about it. Now, there's obviously a trade-off there, right? You see less of it. I sit on all the networking group meetings and say, please can we allow people to debug this? Like, how am I going to go and debug this? And that's kind of what I'm driving at the moment. But we want to move it down, but still give you some visibility into it, but kind of remove as much concern, as much of your concerns as possible, basically.
I think we should take this one last question to the pub, which is what I'm going to tell us all about. Thank you so much, Liam. That was amazing. The amount of questions we have obviously means that everyone wants to discuss this. On that note, we're going to head to a local hostelry called The Fox, which is, I believe, on this street, on the corner of Stratton Street. I'm going to fumble my way through plugging in my projector so I can show you a map, but I don't know if you need it. Does anyone know, how about this? Does anyone know where The Fox is? 2 hands up, follow this man. Anyone else? Yep, Joel over here. I just wanted to say thank you very much to Monzo for hosting us and for supplying the beer at the venue, and Google for supplying the pizza, and wonderful speakers, Liam and Stefan, thank you very much. See you next time.